Hey everyone, what is happening? Today we're going to be talking about names and formulas of compounds. So, ionic compounds are compounds that are made up of positive ions and negative ions. They describe ionic compounds using that name or formula. So this thing called the International Union of Pure and Applied Chemistry, or IUPAC, kind of like Tupac, but IUPAC, decides on the rules that will be used for naming compounds. The chemical name of a compound always has two parts, you guys. So one for each ion in it. Now, let's take an example of sodium chloride for a second. And this is table salt. So if you had eggs this morning, you could have put this on your eggs. Now, the first part of the name is sodium. This describes the positive ion. And the positive ion is always a metal. Always a metal. And if you look on the left-hand side of your periodic table of elements, it'll be positive because it's losing electrons. The second part of the name, which of sodium chloride, is chloride. This describes the negative ion. The negative ion always is always a non-metal. Now, the negative ion gets an "ide" at the end. Now, in this case, chlorine, which is on our periodic table of elements, it changes to "ide." And you'll notice that for a lot of these compounds, we change the non-metal, the ending of it, to "ide." So let's take a quick gander here, and here are some examples of some ionic compounds. Remember, metal and non-metal. So calcium and nitrogen is going to be calcium nitride. Then we've got lithium and fluorine, which is lithium fluoride. Magnesium sulfur, well, that's going to be magnesium sulfide. And finally, we've got sodium and bromine, which is going to be sodium bromide. It's like Brogan. It's, bromide. It's all for the bros. So what we have, let's turn the page. And here's some examples of some ionic compounds. You'll notice we've got potassium bromide on the right-hand side there. In an ionic compound, the number of positive charges must equal the number of negative charges so that the overall compound is electrically neutral. So let's take a look at our charges right here. Remember, they always balance each other out. So we've got 1 K for every Br, so 1 potassium for every Br. Now, let's look at this magnesium chloride here. Magnesium has a charge of 2+. That means we need 2 Cl negatives to balance that out. So what we have is we have a ratio of 1 magnesium for every 2 chlorides. And what we have, and we're going to get into this in a minute, but we've got Mg2+ and Cl-. And this is going to be a review from Science 9, but we've got to swap and drop our charges. And we're going to get MgCl2. And I know a lot of you are, oh, I remember this stuff. Next, we've got aluminum sulfide, and we've got a charge of 3+ and 3+, so that's going to be 6+ altogether. And then we need 3 sulfur ions to balance that out. So if we draw the chemical formula here, we've got Al3+ and S2-, and we're going to swap and drop. And we get Al2S3. That means we need 2 Als for every 3 sulfurs. Now, there's a quick way to draw or write formulas for ionic compounds. First, the first step we always do is we figure out which ions are in our compound and what are their charges. By that, we just look on our periodic table. Next, we're going to swap and drop the charges. So swap and drop, and there should be exactly the same number of positive and negative charges in the ions so that they can cancel each other out. That's something really important to think about. They've got to cancel each other out. So write the formula, then we're going to use the subscripts to show how many of each element there is. Now, if the subscripts are multiples of each other, we reduce the formula. So, for example, Cr4+ and oxygen 2-, we're going to swap and drop these, and we get Cr2O4. Well, these are multiples of each other, and we can reduce them. So 2 goes into 2 once, and 2 goes into 4 twice. So we're going to get CrO2. All right, let's turn the page. We're going to get some practice here. So let's write a couple of these bad boys. We've got silver and oxygen. So we've got silver oxide. I'd like you to try this one yourself and this one yourself, please. And now we're going to write the formulas for the following ionic compounds. Now remember what we did with our rules, or how to write formulas, we wrote down which ions we've got there, and then we're going to swap and drop, and then we're going to use the formulas to tell how many we actually have of each, and they should be multiples. If they're multiples, we'll reduce them. So we've got zinc 2+ and iodine, and with a minus, so we're going to swap and drop our charges, and we get zinc, iodide, and there's a 2 down there. Next we've got Al 3+, and with phosphorus 3-, so we've got Al3, we swap and drop, and P3. Now these are multiples of each other. 3 goes into 3 once, and 3 goes into 3 once, so we actually get AlP. Next we've got calcium and oxygen, and we're going to swap and drop, and we get Ca2O2. And once again, when we have things that are the same or multiples of each other, we would cancel that out to 1, cancel that out to 1, and we get CaO, or calcium oxide. Next, we're going to show how we get the actual ion. So we've got barium, which is Ba2+, and we've got phosphide, which is P3-. So we found our ions from the periodic table of elements, and then we're going to swap and drop, and we get Ba3P2. So what that says is we need 3 Bas to balance out with 2 phosphorus. And if you think about this, let's just take a quick aside here. If we have a Ba2+, Ba2+, and a Ba2+, that's our 3 bariums with phosphorus 3- and phosphorus 3-. Well, this adds up to 6 negative, and this adds up to 6 positive. Well, guess what? Those cancel each other out to get a neutral compound. Next, we got lithium and fluoride. We've got lithium plus and fluorine minus. We're going to swap and drop, and we get lithium fluoride. And next we've got aluminum nitride. So aluminum, Al3+, and nitrogen is N3-. What we're going to do is we're going to swap and drop, and we get Al3N3. And because these are multiples, we can cancel this out to 1, cancel that out to 1, and we get Aln, which is aluminum nitride. Have a good rest of the day.